Most people think making money with Arduino means selling kits or tutorials, but there's much more to it commercially. The real opportunity lies in using Arduino boards to create products that are simple, reliable, and profitable in real-world markets. Everyone asks, how powerful is the Arduino UNO Q? But today we're asking a far more important question. How profitable can the Arduino UNO Q make your designs? In this video, we'll explore how design efficiency, lower cost, lower power consumption, and faster development directly translates into higher earnings. Because in hardware design, every saved component, every watt saved, and every hour saved adds up to real profit. Let's look at how Arduino UNO Q changes the equation from just performance to performance that pays. In many real products, menu kiosks, ticket machines, data loggers, simple HMIs, modern single-board computers carry far more hardware than the job needs. HDMI GPUs, multi-channel audio, and several high-speed ports often sit unused, yet you still pay for them in money, space, and thermal budget. Those extra features typically force a larger power supply, add heatsinks or fans, and introduce more cables and connectors, raising the bill of materials and assembly effort. Power draw is also higher than a lean controller/MPU approach for basic control and connectivity tasks, which means more heat, bigger enclosures, and poorer battery life. On the software side, a full operating system brings imaging, boot management, updates, security patches, and driver changes, adding boot delay and ongoing maintenance risk, for example, storage corruption. When you try to scale a cost-sensitive product, this combination of unused hardware, higher power, and OS upkeep inflates per unit cost and support workload. That hidden over-engineering tax is what we're eliminating next. Modern single-board computers often rely on full Linux-based operating systems, which are powerful but unnecessarily heavy for many embedded tasks. A simple product like a kiosk, data logger, or control panel doesn't need a multi-layer OS, yet developers must manage large system images, services, and dependencies just to perform basic operations. This adds extra steps to development. Booting takes longer, testing becomes slower, and every update or driver change can affect stability. Even small adjustments require revalidation, consuming valuable engineering time. For small design teams, debugging through multiple OS layers can become a serious bottleneck. As a result, projects that should reach the market in weeks often take months, not because the idea is complex, but because the platform is. This is the real over-engineering trap: powerful boards that slow down simple designs instead of accelerating them. Arduino UNO Q brings a major shift in how compact and reliable embedded systems can be built. By combining both an MCU and an MPU on a single board, it unifies control and processing, removing the need for multiple boards or communication layers between them. The built-in Wi-Fi and Bluetooth make connectivity seamless, eliminating extra modules, wiring, and configuration steps. Its rugged power design ensures stable operation even in demanding environments, allowing prototypes to transition smoothly into real-world products. This integration not only reduces the number of components, but also saves valuable engineering hours that would otherwise go into debugging and hardware interfacing. The result is faster development, fewer points of failure, and a lower total cost without compromising performance or reliability. In short, Arduino UNO Q proves that simpler design truly means smarter business. When we compare a typical SBC-based design with an Arduino UNO Q setup, the cost difference becomes immediately clear. A standard SBC solution, with its separate connectivity modules, power supply, cooling components, and assembly overhead, can easily reach around $100 per unit. In contrast, the UNO Q integrates most of these functions on a single board, reducing the total to about $59. That means a saving of roughly $40 per device, or more than $4,000 across just 100 units. Fewer components also mean fewer points of failure, lower wiring effort, and reduced certification costs. This kind of simplification doesn't just make engineering easier, it makes business sense. Every unnecessary module removed, every cable eliminated, and every watt saved directly improves the profit margin. In real terms, fewer parts truly equal bigger savings, the foundation of a more efficient and profitable product strategy. Most single-board computers can run AI, but they don't actually come with AI. Developers usually have to install Python packages, set up TensorFlow Lite, and configure dependencies manually before anything works. Arduino UNO Q changes that approach completely. It comes with App Lab, a ready-to-use environment that already includes AI Bricks modular blocks for vision, speech, and sensor classification. You can drag, configure, and deploy models directly without external SDKs or command line setup. This means students, freelancers, and small teams can start experimenting with AI in minutes instead of days. Whether it's object detection, sound recognition, or pattern learning from sensors, the tools are already built into the board and its software ecosystem. With Arduino UNO Q, AI is not an afterthought, it's the native feature that turns advanced intelligence into an accessible design capability. Truly, built-in AI equals built-in advantage. Arduino UNO Q combines two powerful worlds in one compact design. On one side, its MPU runs a Debian Linux environment that supports Python, AI frameworks, and Linux native tools for model execution. On the other, its MCU, the STM32U585, manages precise, real-time control over sensors, actuators, and user interfaces. This dual architecture means the board can think intelligently while still responding instantly to physical events. Through Arduino App Lab, both layers come together seamlessly. You can write sketches, run Python scripts, and integrate AI models all within a single environment, no switching between tools or configuring complex stacks. App Lab also provides bricks, modular AI components that can be deployed directly for vision, speech, or classification tasks. The result is a balanced system where high-level intelligence and low-level control coexist naturally. In short, dual brains deliver unified intelligence, the hallmark of a truly hybrid design. Menu and information kiosks are some of the simplest yet most common embedded systems found in restaurants, retail spaces, and public areas. These devices only need to display text, respond to touch input, and stay connected to Wi-Fi for basic data exchange. Using a heavy single-board computer for such a task adds unnecessary cost, heat, and maintenance. Arduino UNO Q offers a far more efficient alternative. It drives small SPI or TFT displays directly, connects over built-in Wi-Fi or Bluetooth, and boots almost instantly. No desktop OS or long startup time required. The absence of GPU, fan, and large power adapters makes the design compact, silent, and reliable for 24/7 use. Firmware updates can be managed easily through App Lab without image reflashing or SD card handling. For kiosk developers and integrators, fast boot plus low cost equals the perfect kiosk solution. In an EV charger, every second of uptime matters, both for reliability and user experience. Traditional charger designs often use two boards, one MCU for power and relay control, and another SBC for display and communication. Arduino UNO Q removes that redundancy by combining both functions on a single board. The MCU manages real-time charging logic, safety monitoring, and sensor inputs, while the MPU drives the graphical user interface and connectivity. With built-in Wi-Fi and Bluetooth, the charger can log data to the cloud, handle payments, and receive over-the-air updates without any extra modules. Its rugged power design ensures stable operation even with voltage fluctuations or outdoor conditions. The compact layout simplifies wiring, reduces enclosure space, and cuts overall cost. Through Arduino App Lab, firmware and UI can be updated remotely within minutes. In short, control plus connectivity truly equals smarter charging. Data loggers and sensor nodes demand stability, low power consumption, and reliability, qualities that most full-scale SBCs struggle to provide in long-term field use. Arduino UNO Q addresses these challenges with its dual-brain architecture. The MCU handles uninterrupted 24/7 data acquisition from sensors, ensuring no missed samples or OS-related downtime. Meanwhile, the MPU can process analytics or lightweight AI tasks locally, turning raw data into meaningful insights before uploading. Its instant startup means data collection begins immediately after power, no waiting for an operating system to load. Built-in Wi-Fi and Bluetooth make it easy to send logs to the cloud or wirelessly to nearby devices without external modules. Thanks to its low power draw, UNO Q suits remote, solar, or battery-powered installations. With AppLab, developers can even configure or update firmware remotely. Truly reliable logging plus smart connectivity equals always-on insight. One of the biggest advantages of Arduino UNO Q is how smoothly a design can transition from prototype to a ready-to-market product. What used to require multiple boards, cables, and controllers can now be achieved on a single integrated platform. There's no need for a separate SBC or interface hardware when scaling up production. UNO Q already combines control, connectivity, and processing in one board. This simplicity reduces assembly effort, minimizes wiring errors, and directly increases profit per unit. Through Arduino App Lab, updates and improvements can be rolled out remotely, lowering post-sale service and maintenance costs. For freelancers, startups, and OEMs, that means faster delivery, fewer logistics hurdles, and better project margins. The message is clear: simple design plus high margin truly equals smarter business. Arduino UNO Q proves that real innovation isn't just about faster processors, it's about smarter design. By combining control, connectivity, and AI capability on a single board, it removes the need for extra hardware and complex setup. That reduction directly translates into lower development costs and higher profit per project. Faster prototyping means ideas move from concept to delivery in record time, giving freelancers and startups shorter earning cycles. Built-in Wi-Fi, Bluetooth, and AI tools simplify integration, so less time is spent configuring and more time is spent creating. Whether you're a learner building your first prototype, a freelancer delivering client projects, or an OEM scaling production, UNO Q adapts to every stage effortlessly. It turns technical efficiency into financial advantage, proving, once again, that less complexity truly equals more profit. Thank you for watching this deep dive on the Arduino UNO Q. If you found this analysis useful, don't stop here. Explore our other videos for a complete perspective on this new dual brain board. Watch: is the Arduino UNO Q a Raspberry Pi killer or a worthy competitor? Arduino UNO Q. Is this dual brain board the future of low-cost, rugged, simplified EV charger design? And Arduino UNO question: professional's tool or hobbyist toy? Each video looks at UNO Q from a different angle: performance, design efficiency, and commercial potential. We hope these insights help you build smarter, faster, and more profitable projects. If you enjoyed this content, please like, share, subscribe to the channel for more in-depth analyses, tutorials, and real-world applications of AI and embedded design. See you in the next video.